Hi, everyone. Let's start talking about probability, which is a fascinating subject in and of itself, especially if you love gambling and games of chance. But probability also provides the mathematical foundations, the solid mathematical foundations of the subject of statistics. So we're going to start with discrete probability, as opposed to continuous probability, which we'll talk about later on. How do we work with probabilities when the number of possible outcomes is countable? Like, for example, when you roll a die, there are six possibilities. You can roll a one, a two, a three, a four, a five, or a six. It's not like probabilities involving weights or heights, where you can have a continuum of possible values. The French mathematician Laplace once claimed that probability theory is nothing but common sense reduced to calculation. This is true many times, and we're going to rely on this idea as we introduce probability, but it's not always the case. There are surprising situations where probabilities actually go against common sense, but the probabilities are correct. Sometimes the common sense is wrong. In lesson 11, we're going to start talking about the basics of probability. An event and how likely is an event. That's a probability. Part A, events and probabilities for those events. An event is something that either occurs or doesn't occur. And we often use capital letters, such as A, B, and C, to denote events. For example, an event A could be something like, it rains in my neighborhood today. That either happens or it doesn't. Or an event could be, the die comes up a 4 after it is rolled. Again, that either happens or it doesn't. So for an event, we can assign a corresponding probability, although we're going to talk about the way that we can assign this probability later on. But in principle, we can assign a probability to this event occurring, denoted by P of A. P of A must be a real number between 0 and 1. I say real as opposed to I or 2I. It must be a real number between 0 and 1, inclusive. So the probability of an event A could be 0, it could be 1, or it could be any real number in between, 1/2, 1/3, 0.99, whatever. In fact, you can think of a scale for P of A. If a probability is 0, it means that the corresponding event is impossible. Although that's a powerful thing to say. If I were to ask you, what's the probability that Kanye West will be the next president? You might say that it's very low, maybe 10 to the negative 10th, but it's not impossible. Likewise, if likewise, it's a powerful thing to say that something is certain to happen. I mean, whether you're a fan of President Trump or Joe Biden or whichever presidential candidate, what's the probability that your favorite candidate will win? If you're honest, you're not going to say that the probability is 1. That means certainty. A probability of A happening is 1 if and only if A is certain to happen. Be honest. If the probability of A happening is 1/2 or 0.5, then that's the idea of a 50-50 chance. That's the idea of the probability of a fair coin coming up heads, or the probability of that coin coming up tails. We'll talk about the idea of a fair coin later on. And again, a probability could be other numbers like 0.9, 1 out of 3, and so forth. 1/3. Okay, now if an event A does not occur, then that means the event not A occurs. So for example, if we roll a die, then event A could be the die comes up a 4. The event not A means the die does not come up a 4. So either A occurs or not A occurs, meaning A does not occur. The event not A is called the complement of A, which is denoted by A bar or A with a C superscript. Now remember, probabilities add up to 1. So the probability of A plus the probability of not A, or A complement, must be 1. The sum of the probabilities must be 1. You can think of the area of this pie, this disk, as 1. And then the probabilities for A and not A represent proportions of that total 1 area. So again, the probability of A happening plus the probability of the complement of A happening has to be 1. And we denote the complement of A by either A bar or A with a C superscript. So the probability of not A happening over here, I could have just said not A. The probability of A plus the probability of not A is equal to 1. Either A happens or not A happens, the complement. Now, if you solve for P of not A and you subtract P of A from both sides, we get that the probability of the complement of A, not A, that is the probability of A bar or the probability of A with the C superscript, that probability is 1 minus the probability of A. Again, the probability of not A or the complement of A is 1 minus the probability of A. So for example, if the probability that event A happens, where A is the event, it rains in my neighborhood today. If the probability that it rains in my neighborhood today, if the probability that A happens is 0.3, then the probability that it does not rain in my neighborhood today is going to be given by 1 minus 0.3 or 0.7. These complementary probabilities have to add up to 1. 0.3 and 0.7 have to add up to 1. I don't care if you put the 0 in front or not. One advantage is that it helps people remember that there's a decimal point there. But the 0 in front is optional. Now, how do we round off probabilities? Well, sometimes in math, we prefer exact values. And exact values are more often written as fractions. But in general, probabilities may be written as fractions or decimal numbers. Percents are also possible, but they're a bit more controversial because sometimes students mess up the math with percents. Now, I will tell you how to round off things in a typical problem, but when in doubt, we often round off probabilities to 3 significant digits or significant figures, sig digs or sig figs. And what's an example of something being rounded off to 3 sig digs or sig figs? Well, if you see 0.333, that's an example of a decimal written out to 3 decimal places or 3 significant digits. 3 significant digits. Also, something like 0.00703 or 0.703%. Now, remember, when you're dealing with significant digits, take a look at a blown up version of the number here. We don't count the 0 to the left of the decimal point. We never count that. In fact, you don't even have to write that down. Now, if you're counting decimal places, you do count the zeros in red over here, in addition to the digits after the zeros. So we would say that this number is written out to 5 decimal places after the decimal point, 1, 2, 3, 4, 5. 5 decimal places. However, if you're counting significant digits or significant figures, which is probably more common, then you would not count these zeros in front, even after the decimal point, at least the zeros immediately following the decimal point, but you would count the 7. You would count this 0 because it's following a significant digit. 7 is a significant digit. Any zeros following a significant digit would be counted. And you also count the 3. In fact, the 3, even if that were a 0, you would also count it. So if it's 0.00703 or even 0.00700, we would say that this is written out to 3 sig digs or sig figs, 3 significant digits or 3 significant figures. All right. Now, if we need final answers to be rounded off to, say, 3 sig digs or sig figs, then make sure that you round off intermediate results, uh, uh, well, either state them exactly or round them off to more sig figs, maybe at least twice as many. So if we ask for at least 3 sig figs in your final answer, then we might want at least 6 sig figs in intermediate results. Certainly, if we want something written out to 3 sig figs at the end, you don't want to just round off to 1 or 2 in the middle. Even 3 might be a little risky. So at least twice as many, or 6, might be the safer bet. Even safer would be to carry exact fractions such as 1/3, but sometimes that's not practical. Now, if you're dealing with a probability close to 1 or 0, you may want more than 3 sig figs if a probability is close to 1 or 0. So for example, if a probability is 0.9999987, then you may not want to say the probability is 1. That would mean certainty. You might actually want to state this to many sig figs. The same is true for a probability close to 0. The probability that Kanye West will be elected president may be something like 0.00001, but it's not quite 0. Again, it's a powerful thing to say that an event is either impossible or certain, so you might want to take it out to more sig figs. All right, so we've talked about some of the rules for probabilities, but now how do we judge these probabilities? Next time we're going to talk about ways to figure out or estimate these probabilities. Next time.